Following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I'll respond as soon as I can. All righty, so today we're going to go on to section 9.2. And that has to do with fractional exponents, which I will explain here in a bit. But the first thing I want to do is I want to go back and quickly review something that would have been covered if you've taken Math 84 or Math 85 or a beginning algebra class. Most likely you covered properties of exponents. So we're going to take a look at that. In the textbook, it's in section 5.2. So if you want to look that up for further review. Anyway, so let's go through some rules briefly. Let's say we have a situation like x cubed times x squared. So we're multiplying two powers with the same base. The shortcut of doing that is just to add the exponents. So in general, we get a statement like this: x to the m times x to the n equals x to the m plus n. Other examples of this might be y to the 4th power times y to the 7th power equals y to the 11th power. Okay, so we've got this rule. Second rule, this first rule is called the product rule. The second rule, called the power rule, is where if you have a power raised to a power, in this case, you multiply the exponents, or in general, x to the m raised to the n power would be x to the m times n power. Let's say you've got z to the 4th cubed. That would be z to the 12th power. Now, don't confuse this with the first rule. If you had z to the 4th times z to the 3rd, that's z to the 7th power. So when you're multiplying two powers with the same base, you add the exponents. But when you have a power raised to a power, you multiply the exponents. So be careful of those two. If we have, let's see, a product like xy raised to a power, we take that power and attach it to each factor inside of that product. So in general, if we have xy to the n, that's x to the n, y to the n. So if we have, let's say, 4y, the quantity cubed, that would be 4 cubed y cubed. And going on, since 4 cubed is 64, you'd get 64y cubed. So a product raised to a power, we attach that power to each factor of that product. Okay, let's say we have this situation, w to the 5th divided by w squared. So we're dividing two powers with the same base. In this case, we subtract the bottom exponent from the top exponent and attach them to the common base. Or if we have x to the m divided by x to the n, that is x to the m minus n power. Again, the quotient rule. Okay, let's see. If we have a quotient raised to a power, we attach the power to both the numerator and the denominator of the quotient. 3 to the 4th power is 81. That would be over x to the 4th. So if we have something like x divided by y to the n power, that's x to the n power over y to the n power. Power of a quotient. Some other cases. If you have something raised to the 0 power, that's 1. And if you have something raised to the 1 power, you don't need to list the exponent. In fact, x is equal to 1 times x to the 1 power all over 1. There's all these things that are implied, whether they're written or not. And finally, the case of negative exponents. Let's say you've got 4 to the negative 2 power. That's 1 over 4 to the positive 2 power, or 1 over 16. So if you take a base raised to a negative exponent, that's 1 over the base raised to a positive exponent. You can also go the other direction. Let's say you have 1 over x to the negative 3 power. That would become x to the positive 3 power over 1, or just x to the positive 3 power. So you can move it down below or move it up above. Crossing the line there, it changes the sign of the exponent. Okay, let's see. Oh, you could also have something like this. Let's say you've got x to the negative 3 over y to the negative 2. So you could switch them both, which would make them both positive. Okay. Also, let's say you've got something like this. You could do the reciprocal, which again would change the sign of the exponent, and then apply it to each of the base, or to the numerator and the denominator as well. This is a very quick review. If you need more help on that, please contact me. I'll be happy to go over that in more detail. But now we're going to move on to section 9.2. All right, we've been studying radicals. Let's say we have the cube root of 8. Okay, I can rewrite this radical expression in exponential form. The base, or the radicand in this case, is 8. The index of the radical becomes the denominator of the exponent. So the cube root of 8 becomes 8 to the 1/3 power. Keep in mind there is an implied 1 on that 8, and that 1 is right there. Okay, let's look at some more examples. Let's say I've got 2 squared and take the 5th root of that. That would be 2 to the 2/5 power. So the inside exponent becomes the numerator of the exponent, and the index becomes the denominator of the exponent. All right. Now, the cube root of 8 is equal to 2 because 2 cubed equals 8. So 8 to the 1/3 power should also equal 2. How can we get that on our calculator? By doing the following. Put in 8, then use the little caret key, which is over on the left column, right about there. And then we put the exponent in 1 divided by 3. But we need to be careful. We need to put parentheses around the exponent, because if we don't, if we just write this, the calculator thinks you've got 8 to the 1 power divided by 3. You need to tell the calculator that that entire quotient is the exponent. So again, I've got 8 raised to the parentheses 1 divided by 3 power. And if we do that correctly, we should get an answer of 2. All right. So now we're going to go through and evaluate some expressions. 125 to the 1/3 power. So that is equivalent to the cube root of 125, which would be 5. 5 times 5 times 5 is 125. 81 to the 1/4 power, that would be equivalent to the 4th root of 81, which is 3, because 3 times 3 times 3 times 3 is 81. Let's see here. Negative 216 to the 1/3 power. Let's see, I think, well, let's see, 7 times 7 times 7 is, no, that's too big. 6 times 6 times 6. So this would be negative 6. Okay, it's the same thing as taking the cube root of negative 216, which is negative 6. Now, what about, let's see here, this situation. Negative 64, x to the 8th power, all raised to the 1/8 power. That would be negative 64 to the 1/8 power, x to the 8th to the 1/8 power. The problem is we can't take an even root, that would be like the 8th root of a negative number. So this is not real. Okay, let's see here. 1/4 to the 1/2 power would be 1 to the 1/2 power over 4 to the 1/2 power, which raising something to the 1/2 power is like taking the square root of it. The square root of 1 is 1, the square root of 4 is 2. So 1/4 to the 1/2 power is 1/2. Okay, let's see here. What about this one? Negative 16 to the 1/4 power. Well, again, we're trying to take an even root of a negative number, so that's not real. Now be careful. What about that situation? Well, in the first example, the negative is part of the base. So here we're trying to take an even root of a negative number. But in the second example, the base is just the 16. If we want that negative as part of the base, we have to include it. So this would be negative because of that, and then the 4th root of 16, which is 2. So be careful, what is the base you're dealing with? All right. This says, simplify each expression, assume that the variables can be any real number. Earlier on, it said something like, all the variables are unrestricted, same thing, and use absolute value symbols when necessary. All right, so we've got the quantity 4x to the 4th, all to the 1/2 power. So we've got a product raised to a power. We're going to attach that power to each factor inside, okay? 4 to the 1/2 power, the square root of 4 is 2. X to the 4th power to the 1/2 power, recall that a power raised to a power, you would multiply the exponents. 4 times 1/2 is 2, so this becomes x squared. Now, I'm taking a square root, which means I can't get a negative answer. However, x squared wouldn't be negative anyway, because if x was negative, x squared still would be non-negative. So I don't need any absolute value bars there. Let's take a look at this problem, however. X squared to the 1/2 power. All right. So we're taking an even root. This would be what? X to the 2/2, or x to the 1, or just x. But since we're taking an even root, our answer can't be negative. But since the variable is unrestricted or can be any real number, in this case, we need absolute value bars. How about this one? X cubed to the 1/3 power. Well, this would be x to the 3/3, or x to the 1, or just x. But here, since I'm taking an odd root, I can get a negative answer, so I don't need absolute value bars. In fact, it would be wrong to include them. Let's see here. How about this one? Negative 64 t to the 9th, all to the 1/3 power. So that would be negative 64 to the 1/3 power, t to the 9th to the 1/3 power. I'm taking an odd root. I can take an odd root of a negative number. So negative 64 to the 1/3 power would be like the cube root of negative 64, which is negative 4. T to the 9th to the 1/3 power, you'd multiply the exponents. 9 times 1/3 is 3, so I get t cubed. Again, I'm taking an odd root, so a negative answer is acceptable. I don't need any absolute value bars here. Let's see here. Okay, now it says evaluate each expression. 36 to the 3/2 power. Now we have a situation where we're taking a root and we're taking a power, okay? So I can do it one of two ways. I can raise it to the 3rd power and then take the square root of that, or I can take the square root of it and then raise it to the 3rd power. As long as both of them are real, we can do it in either order. Now, 36 cubed to the 1/2 power, I'm definitely going to have to use my calculator on that one. But 36 to the 1/2 power, that would be 6, and then 6 cubed, well, I might even use my calculator on that one as well. Let's see, 6 cubed is 216. If I do it this other way, 36 cubed, this is 46,656, and then we're taking that to the 1/2 power, we still get 216. But in general, if they're both real, it's easier or better to do the root first, to tear it down to something smaller and then build it back up. I want to back up for just a second and write this statement. X to the 1/n equals the nth root of x, which the way I stated it earlier was to say the index is the denominator of the exponent. Okay. Let's see here. How about 27 to the 2/3 power? So I can either take 27 squared to the 1/3 power, or I can take 27 to the 1/3 power squared. I opt for the second choice. 27 to the 1/3 power, or the cube root of 27 is 3, and then 3 squared is 9. So I can do that without the calculator. 27 squared and then taking the 1/3 power, not so nice, though the answer should still be 9 as well. All right. How about this one? 4/9 to the 3/2 power. So that's 4 to the 3/2 power over 9 to the 3/2 power, which is 4 to the 1/2 power cubed over 9 to the 1/2 power cubed. Again, I'm going to take the root and then the power. 4 to the 1/2 power is 2. 9 to the 1/2 power is 3. 2 cubed is 8. 3 cubed is 27. So 4/9 to the 3/2 power equals 8 divided by 27. Okay. It says, simplify each expression. All variables represent positive real numbers. So in this case, we don't need to worry about absolute value bars. They're saying, assume all the variables are positive. Okay, so we've got 25 x to the 4th, all raised to the 3/2 power. I have a product raised to a power, so I'm going to attach the outside power to each factor inside. 25 to the 3/2 power would be 25 to the 1/2 power cubed. X to the 4th to the 3/2 power, we would multiply the exponents. 4 times 3/2 is 12/2 or 6. So this becomes x to the 6th power. 25 to the 1/2 power, or the square root of 25, is 5. So then I have 5 cubed times x to the 6th power. 5 cubed, 5 times 5 is 25, times 5 is 125. So my final answer becomes 125x to the 6th power. Let's see here. 1/16 x to the 8th, y to the 4th power, all raised to the 3/4 power. So we have a product slash quotient situation inside the parentheses. So we're going to attach the outside exponent to all the factors of the numerator as well as the denominator inside the parentheses. So I've got 1 to the 3/4 power over 16 to the 3/4 power, x to the 8th to the 3/4 power, y to the 4th to the 3/4 power. So now taking those one at a time, 1 to the 3/4 power. Well, the fourth root of 1 cubed would be 1 cubed, which is 1. Okay. Then this one, a power raised to a power. We multiply the exponents. 8 times 3/4 is 24/4 or 6. So x to the 6th power. Y to the 4th to the 3/4 power. Again, we multiply the exponents. 4 times 3/4 would be 3. So y cubed. And then in the denominator, 16 to the 3/4 power would be 16 to the 1/4 power cubed. 16 to the 1/4 power is 2. 2 cubed is 8. So we get that. And we could write that as 1/8 x to the 6th y cubed, or x to the 6th y cubed all over 8. Either of those. All right. Let's see here. It says change each radical to an exponential expression. So we're not simplifying it, we're just converting it from one form to the other. The 5th root of 8abc would be the quantity 8abc to the 1/5 power. The 7th root of 7p squared q would be 7p squared q to the 1/7 power. The square root of the quantity x squared plus y squared would be the quantity x squared plus y squared all to the 1/2 power. Now we're going to change an exponential expression into a radical expression. 6x cubed y to the 1/4 power becomes the 4th root of 6x cubed y. 7a squared b squared to the 1/5 power becomes the 5th root of the quantity 7a squared b squared. The quantity x cubed plus y cubed to the 1/3 power becomes the cube root of the quantity x cubed plus y cubed. All right. Now we're going to look at dealing with some negative exponents. So 4 to the -1/2 power becomes 1/4 to the +1/2 power, which is 1/, what? The square root of 4, which is 2. 49 to the -1/2 power becomes 1/49 to the +1/2 power, which is 1/7. Let's see here. The quantity 25/49 to the -3/2 power. Remember, we can take the reciprocal of the base. So we'll have 49/25, and that changes the sign of the exponent to a +3/2. Now we can go in and apply the exponent to both the numerator and the denominator. Taking the numerator, I can do the the root first and then the power. So that's, let's see, 7 cubed. I think it's 343. Okay. And then taking the root and then the power, 5 cubed, which is 125. So basically, yeah, I've got here, let's write it this way. So 343 over 125. 343 divided by 125 would be our final answer. So the key there, we can make this exponent positive by doing the reciprocal of the base. How about this one? 1 divided by 16 to the negative 5/2 power. So I can move the 16 to the negative exponent up on top and make it a positive exponent all over 1. I don't really need that 1 in the denominator. So this would be 16 to the 1/2 power to the 5th power. Well, the square root of 16 is 4. So now I've got 4 to the 5th power. Let's see what that is. 4 to the 5th power is 1024. Okay, let's see here. This says simplify each expression, write the answers without negative exponents. And even if the directions don't say that, unless they specifically say to use negative exponents in the answer, you're going to want to make the exponents positive. The only exception to that is scientific notation, and we aren't dealing with scientific notation here. So I've got 9 to the 3/7 power times 9 to the 2/7 power. So the rule says when you're multiplying two powers, with the same base, you add the exponents. So this would be 9 to the 3/7 plus 2/7 power, which is 9 to the 5/7 power. Okay, let's see here. 5 to the 1/3 power times 5 to the negative 5/3 power. We're multiplying two powers with the same base. So we're going to add the exponents and attach them to the common base. So this is 1/3 plus negative 5/3, which is 5 to the negative 4/3, which is 1 over 5 to the positive 4/3. Let's see here. Okay. This one. B to the 3/5 power times b to the 2/5 power, the whole thing to the 8th power. So inside I've got b to the 3/5 plus 2/5, which is 5/5, which is 1. B to the 1 power is just b, so I've got b to the 8th power. Let's go through that again. B to the 3/5 times b to the 2/5 all to the 8th power. That would be b to the 3/5 plus 2/5 to the 8th, which is b to the 5/5 to the 8th, which is b to the 1 to the 8th, which is b to the 8th. Okay, that's just writing out all the little steps that I verbalized before. All right. I would ask if there's any questions, but there's nobody else here, so just me talking to myself. All right, let's see here. 2 to the 5/6 power times 2 to the 1/3 power over 2 to the 1/2 power. So in the numerator, we're multiplying two powers with the same base. So we're going to add the exponents and attach it to that common base. Well, let's see here. 5/6 plus 1/3. 5/6 plus 1/3 would have a common denominator of a 6. So we'd have to multiply. 5/6 would be just like it is. 1/3 multiplying it by 2 over 2 would become 2/6. So that's going to give us 7/6. So now we're going to get 2 to the 7/6 over 2 to the half power. But now we're dividing two powers with the same base. So we're going to take the base raised to the top exponent minus the bottom exponent. Well, let's deal with that. 7/6 minus a half. Common denominator would be 6. 7/6 stays as it is. 1/2 will multiply by 3 over 3. So we get 7/6 minus 3/6, which is 4/6, which is 2/3. So our final answer is 2 to the 2/3 power. Okay, lots of review of arithmetic there, adding and subtracting fractions. You've got to get a common denominator, etc., etc. Okay, in this situation, we're going to distribute. So we've got y to the 2/5 power times y to the negative 2/5 power plus y to the positive 3/5 power. So distributing, we get y to the 2/5 times y to the negative 2/5 plus y to the 2/5 times y to the 3/5. Then dealing with each separate piece. This first one, y to the 2/5 times y to the negative 2/5. We'd add the exponents and get y to the 0 power, because 2/5 plus negative 2/5 is 0, but y to the 0 power is 1. The second one, y to the 2/5 times y to the 3/5 would be y to the 5/5, which is y to the 1, which is just y. So I end up with 1 plus y as my final answer. And let's see here. X to the 4/3 times the quantity x to the 2/3 plus 3x to the 5/3 minus 4. So distributing, we get x to the 4/3 times x to the 2/3 plus x to the 4/3 times 3x to the 5/3 minus x to the 4/3 times 4. So this first one, x to the 4/3 times x to the 2/3, we're going to add the exponents. 4/3 plus 2/3 is 6/3, which is 2. So I get x squared. The second product, x to the 4/3 times 3x to the 5/3 would be 3x to the 9/3, which is 3. So 3x cubed, and then minus, and this is just going to be 4x to the 4/3. So there's our final answer. All right. Next, it says, use rational exponents to simplify each radical. So what we're going to do, this may seem crazy, but this is how we're going to do it. We're going to take a radical expression. We're going to convert it into an exponential expression. Then we're going to simplify it, and then we're going to convert it back into a radical expression. Keep in mind that when there's no index written, there's an implied 2. So I can just write the square root of 5 without that 2 as an index written. Okay. How about this? The 6th root of 7 cubed. So that would be 7 to the 3/6 power, which is 7 to the 1/2 power, which is the square root of 7. The 12th root of 13 to the 4th power would be 13 to the 4/12 power, which is 13 to the 1/3 power, which is the cube root of 13. So converting it into exponential form, reducing the fractional exponent, converting it back into radical form. All right, now let's see here. We've got the 10th root of x squared y squared, which would be x squared y squared to the 1/10th power, which would be x squared to the 1/10th power, y squared to the 1/10th power, which is x to the 2/10ths or 1/5, y to the 2/10ths or y to the 1/5, which is xy to the 1/5 or the 5th root of xy. That seems like such a long ways to go. Eventually, we'll be learning some more rules that will make that process easier, but we're not there yet. Okay, how about this one? The 4th root of the square root of x. So that would be the 4th root of x to the 1/2 power, because the square root of x is x to the 1/2 power. And this would be x to the 1/2 power to the 1/4 power, because the 4th root would be the 1/4 power. But now we're going to multiply the exponents. 1/2 times 1/4 would be 1/8. So we've got x to the 1/8 power, which is the 8th root of x. And there you have it. Okay, let's see here. It says, use a calculator to evaluate each expression. Round to the nearest hundredth. All right. 50.5 to the 1/4 power. So on my calculator, I'm going to type in 50.5, then the power key, parentheses, 1 divided by 4, close parentheses, equals. And let's see what I get. 50.5 raised to the power, parentheses, 1 divided by 4. I'm getting 2.665771033. It said round to the nearest hundredth. So that would be right there. We go one place to the right, 5 and above rounds up, 4 and below rounds down. So 2.67 would be my final answer. Okay, so I strongly suggest that before you start this assignment, you might want to go back to section 5.2, as I mentioned at the beginning, and review those properties of exponents so you don't get hung up on them as you're doing these problems using rational exponents, that is, exponents that are fractions. Well, that's all I have for you today. So I'm going to stop the recording and we'll see you later.